Hello everyone. Today we are going to analyze this simply supported beam. In this beam there is uniformly distributed load 12 kN per meter. It acts for a distance of 2 meter from the point A to the point C, and there is uniformly varying load which varies from 12 kN per meter at C to 36 kN per meter at D. To make the numerical easy, let us draw this line from C to D. Now there is uniformly distributed load at the magnitude of 12 kN per meter from the point A to the point D. This height will be 36 minus 12, so it will be 24. So there is a uniformly varying load which varies from 0 at C to 24 at D. To find RA, let us take moment about B. In this case we have to follow right hand side rule. RA is acting in the clockwise direction, so it will be positive, and the distance is 2 plus 2 plus 1, so it will be 5 RA. The UDL is acting in the anti-clockwise direction, so it will be negative. For the UDL and UVL, we have to multiply the area with the centroid distance. The UDL is in the shape of rectangle. The area is length into breadth. Here the length is 2 plus 2, so it will be 4, and the breadth is 12. So this is the area. We know that the centroid of a rectangle lies in the center. Here for the rectangle, the center is in the point C. From the center, the distance to the point D is 2, but we are taking moment about B, so we have to add the remaining distance as well, which is 1. The UVL is acting in the anti-clockwise direction, so it is also negative. Let us take this triangle. We know the area formula of the triangle, half into BH. Here the breadth is 2 and the height is 36 minus 12, so it will be 24. So this is the area, and the centroid distance about D is 1 upon 3 into breadth. Here the breadth is 2, so it is 1 upon 3 into 2, and then we have to add the remaining distance up to B, which is 1. For RA, we will get 36.8 kN. To find RB, let us take a moment about A. In this case, we have to follow left hand side rule. RB is acting in the anti-clockwise direction, so it will be positive, and the distance is 5, so it is 5 RB. The UVL is acting in the clockwise direction, so it will be negative. This is the area of the triangle, and the centroid distance about C is 2 upon 3 into breadth. Here the breadth is 2, so this is the centroid distance. Then we have to add the remaining distance up to A, which is 2. The UDL is acting in the clockwise direction, so it is also negative. This is the area of the rectangle, and from the center to the point A, the distance is 2. For RB, we will get 35.2 kN. Alternatively, using this rule, we can easily find RB. RA and RB are acting upwards, so both of them are positive. The UDL and UVL are acting downwards, so both of them are negative. For both of them, we have to take the area. This is the area of the rectangle, and this is the area of the triangle. For RB, we will get 35.2 kN. Using the right hand side rule, let us find the shear force values at A and at C. Shear force at just left of A will be 0, and at just right of A will be RA, which is acting upwards, so it will be positive. Let us find the shear force at C. RA is acting upwards, so positive. The UDL is acting downwards, so negative. For the UDL, we have to take the area up to C. The area of the rectangle is 12 into 2. For the shear force at C, we will get 12.8. To find the shear force values at B and at D, let us use left hand side rule. Shear force at just right of B will be 0, and at just left of B will be RB, which is acting upwards, so it will be negative. Let us find the shear force at D. Up to D, we have only RB, so here also we will have the same shear force, minus 35.2. Here you can see the shear force diagram. Under the UVL, the diagram should be in the shape of a parabola. In this point, the shear force becomes 0. So in this point, there will be maximum bending moment. We have to make a section in this point and to find the distance. You can see that in that point, I have made a section XX at a distance of X from C. We need to find this height. For the distance of 2, the height of the triangle is 36 minus 12, so it will be 24. So for 2 it is 24, but we need the height at the distance of x. In this way we will get the height as 12x. Using the right hand side rule, let us find the shear force about the section. RA is acting upwards, so positive. The UDL is acting downwards, so it will be negative. And the area of the rectangle up to the section is 12 into 2 plus x. The UVL is also acting downwards, so it is also negative. Let us take this triangle. We know the area formula of the triangle, half into BH. Here the breadth is x and the height is 12x, so this is the area. We can equate this to 0. Finally we will get this equation. Using a calculator we can solve this equation. For x we will get 0.77 meter. Using the right hand side rule, let us find the moment about C and about the section. First let us find about C. RA is acting in the clockwise direction, so positive, and the distance is 2. The UDL is acting in the anti-clockwise direction, so it will be negative. For the UDL and UVL, we have to multiply the area with the centroid distance. The area of the rectangle up to the point C is 12 into 2. And we know that the centroid of a rectangle lies in the center. So from the center, the distance to the point C is 2 upon 2. For the moment at C, we will get 49.6. Now let us find the moment about the section. RA is acting in the clockwise direction, so positive, and the distance is 2 plus 0.77, so it will be 2.77. The UDL is acting in the anti-clockwise direction, so it will be negative. The area of the rectangle up to the section is 2 plus 0.77, that is 2.77 into 12. And the distance from the center of the rectangle to the section is 2.77 upon 2. The UVL is acting in the anti-clockwise direction, so it is also negative. Let us take this triangle. The area is half into BH. Here the breadth is 0.77 and the height is 12x, so it is 12 into 0.77. And the centroid distance about the section is 1 upon 3 into breadth. Here the breadth is 0.77, so it is 1 upon 3 into 0.77. For the moment about the section, we will get 54.98. To find the moment at D, let us use the left hand side rule. RB is acting in the anti-clockwise direction, so positive, and the distance is 1. For the moment at D, we will get 35.2. We know that in the simply supported ends, the moment will be 0. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.